Good morning, everyone. Welcome to today's European Water Association webinar on the digitalization in the water sector, wastewater treatment process. I think some of you are still coming in, but we will slowly start with a short introduction on the European Water Association. What are our activities? Just one slide. And we will start slowly then after it with directly the main speakers. So welcome again. The European Water Association, we are an independent, non-governmental and non-profit organization dealing with the management and improvement of the water environment. We have members from nearly all European countries, and we have several members categories. We have national members that are normally national association, either from wastewater or from drinking water, and sometimes both. We have corporate members and research members, and we aim to be a platform for key discussions on technical and political and policy issues in Europe. And we also organize conferences, workshop meetings, special working groups of experts. We are active on social medias, where you might have heard about today's event. And because I also forgot, my name is Arthur Guichet, Deputy Secretary General for the European Water Association, and I'm glad to have all of you with us today, as well as all the speakers. I would also like to so that's the rule from our webinar for today. So you participants are all muted and cannot switch on your camera. So please, for your question, use the chat box and the Q&A function. I saw already some of you chatting, so that's good. You know where it is. As written here, you cannot use the raise hand function. So please really use the chat box and Q&A. You will receive all the presentation after today's event, and a recording of this YouTube on this webinar will be available on our YouTube channel by the end of the week. Once again, thank you for respecting this, and I would also like to thank Bentley, who is one of our new corporate members and sponsor from today's webinar, and the sponsorship is allowing us to do this webinar free of charge for the participants. Bentley's mission is to provide innovative application and service for the enterprise and professionals who design, build, and operate the world's infrastructure, advancing both the global economy and the environment for improved quality of life. In particular, Bentley has helped water utilities, government, and engineering firms around the world demonstrate excellence and cutting-edge digital advancement in water, wastewater, and stormwater infrastructures. So thank you again for being a sponsor for us today, as well as being a really active corporate member from us. And now that you all have the rule from the webinar, I think we'll move on to the first and keynote presentation from today. She will be given by Dr. Marianti Toraredu from the European Union Agency of Cybersecurity, ENISA. Dr. Terraredo, you are a cybersecurity expert at ENISA, then working to support the implementation of the Network and Information Security Directive. Prior to joining ENISA, you worked on critical infrastructure protection, risk assessment, and hybrid threat for the European Commission Joint Research Center. You were coordinating the ANSIP Chemical and Biological Risk to Drinking Water thematic group. You also have an adjunct lecturer at the Department of Informatics in Athens University of Economics and Business, and you hold a BS on Informatics and a Master's on Information System and a PhD in ICT Security and Critical Infrastructure Protection. And today you will be talking about navigating the water of cybersecurity, unveiling the impact of NIS2 directive on drinking and wastewater companies. It's a pleasure to have you here with us. Please, the floor is yours.
Thank you. Thank you for the introduction. Thank you for the invitation. I'm very happy to be with you here today. Let me see if the sharing of my slide works. Yes. As you mentioned, I work for the European Union Agency for Cybersecurity. So my background is cybersecurity, but due to my previous employment, I have a connection with the drinking water sector because I was working not on cybersecurity, but on security topics in my previous employment. So after I joined ENISA, although we do not have significant activity focusing on the drinking and wastewater sectors, I'm the responsible person trying to start some cybersecurity initiatives in the sector. So I'm very happy to join you here today, and I look forward also to the other speakers to see their point of view. Our mission is to achieve a high common level of cybersecurity across the European Union. And we do that working together with the European Commission, but also with the national competent authorities for cybersecurity and with the industry, so with the companies themselves. And water sector is one of our focus areas, and I'll explain why. What we try to do usually as a first step is to see when it comes to cybersecurity is to try to investigate whether a particular sector faces cyber threats and which ones are these, to what extent, whether the sector is mature. And I'll give you some explanations on what we have collected for the sector so far. We have a very long tradition at ENISA, more than 10 years. We are issuing threat landscapes. The idea is we look back usually back for a 12-month period. We record open source information for cyber security incidents, and we give our findings and our conclusions so that we can inform practitioners in their risk management processes. The latest report we issued, and you can find it online, it's a very lengthy document, so grab a coffee before you start reading. It covers the latest cyber threats, what are their trends. We analyze actors as well, who are the ones active in Europe. And we also try to see how the various sectors of activity are affected. I'll give you some numbers. For the EU environment alone, last year we managed to collect public information for almost 2,500 incidents. For the water sector, and in the EU, we collected 13 cyber incidents. So a very small fraction. So I cannot give you significant statistics. I don't have a big number of incidents. But this lack of information on incidents can mean various things, either that we don't have yet because the sector is now being digitized, or that there are incidents and they are not detected, or there are incidents and they are not reported. So it can mean many things. I'll try to give you my personal view at least. We always focus on the EU, but we look also at the global landscape, because there may be incidents happening abroad that can affect EU-based companies. So for the water sector in particular, a lot of our incidents are not in the EU environment, but for example, in the US or in other areas where there is geopolitical tension and that influences the cyber landscape. Here are the trends. We collected the incidents for a 12-month period. The reporting period is from July 2022 until June 2023. You see that not all months we managed to find cyber incidents for the water sector. And here are some statistics, the types of threats that we actually observed. So ransomware is the prominent attack. This is a finding for almost all other sectors, so it's a widespread issue. And we recorded also data theft or data breaches, some denial of service attacks, and what we call intrusions. This is when we do not have sufficient information on what actually happened. We know that there's been a cyber attack, but we don't know the details. There's also cases of malware and cases of phishing being recorded. Just to give you an overview of what types of attacks we see. The statistics do not mean much because the number of incidents is very, very low. So it's not a huge sample. there is another source of information, not the openly available information. In the EU, under the Network Information Security Directive, when there is a significant incident, incident of significant impact, and that can mean many things. There are thresholds, specific thresholds, that if a disruption, for example, is above a certain time duration, then it has to be reported to the national competent authorities. So each company, and in this case, because we are talking about the first edition of the NIS directive, we're talking about drinking water companies. There were 34 incidents reported to national competent authorities in 2022, and you can see some statistics here. The majority of the disruptions took place because of system failures. So faulty software or hardware, something going wrong during an update, a human error while administrating a system. So accidental disruptions. However, an 80% is intentional, and it's what we usually reflect on our cyber threat landscapes. And it can be, as you can see, malware, viruses, ransomware, and so on, or phishing. And then we have 12%, which is human errors. And these incidents cover all types of systems that are used by water companies, both the industrial part and the normal ICT or a building and so on. Just to give you another source of information when it comes to failures. Because we did not have a big number of incidents, we've been tracking down what types of incidents we have for the water sector since 2019. Here are some headlines just to give you an impression what a cyber attack may mean for a water company. We had cases in the past where a former employee who was disgruntled maintained its user credentials, its access wasn't interrupted, and he tried, for example, to shut down cleaning and disinfecting procedures. In other cases, we had cyber criminals doing the attack, and they tried to modify water parameters or attempted to increase chlorine or some other substance to affect water quality. We have cases where flaws in particular industrial components are being reported and in some cases exploited, or widespread ransomware infections, which affect the SCADA systems as well, not just the ICT traditional systems, the IT systems of a company. I think this is what's of particular interest, the things that can cause big disruptions or may affect safety of citizens. This is where we focus on. There have been cases in the past of supply chain attacks, in the sense that the ransomware was not in the water company, it was on a supplier, and then all its clients, which in one case was 200 public water suppliers, were affected, and they couldn't do their customer service function. What it's being targeted in data breaches or data thefts is usually customer information, especially payment, related to payment and financial information. This is for fraud, there's financial motivation behind it. Or we have recorded cases of phishing. A high-ranking employee with privileged access to various systems was hacked, and then this was the way in for the attackers. These are some examples of what we see in your sector. And I have a recent case. A few days ago, the US-based Water Information Sharing and Analysis Center issued an advisory. There was an attack in a water authority, and there was a cyber group which has links to Iran that claimed the attack. But what's very interesting is the advisory that that happened right after from the US Cybersecurity and Infrastructure Security Agency. And what they said was that the attack was due to unaffected PLC that's widely used. by exploiting cybersecurity weaknesses, for example, poor password security and the fact that the PLC was exposed to the internet. This is a very recent case where we have a confirmed attack because of a vulnerability in a component of the industrial system being used. These PLCs, the particular brand is used in the EU. With a search, we could find over 900 devices operating in the EU and open to exposed to the internet in a lot of the EU member states. So it's not an imaginary threat that can happen to you when you digitize your system. It's already here. That's my point. We already have attacks, maybe fewer in numbers, but there is potential. There is ground for attacks in the future, so you should be preparing your cybersecurity measures. Just a summary of the findings. As I mentioned, system failures is the majority, the major cause of disruptions. But when we look at intentional threats, ransomware, similar to what we see in other sectors, with the main motivation being financial gain. We have denial of service attacks for disruption. In the majority of the cases, this is linked to hacktivist activity and the geopolitical situation. So we see it in particular countries, for example, NATO affiliated countries linked with the situation in Ukraine, with the war in Ukraine. We see supply chain attacks taking place, and of course, phishing is the main point of entry. This applies to all sectors. This is a global finding that we see every year in our threat landscapes. I think what's particularly interesting for your sector is that we've seen the safety of citizens being targeted in some occasions, often not, in most cases it's not successful, and the company switches to manual control, or they have means to detect that something is not right. However, we can record the intention of the attackers, and I think this is very important for you when you try to manage risk. Another finding is that in a lot of these cases, if basic cybersecurity measures were in place, then the attacks would not take place. We do not see highly sophisticated attacks. It's just poor passwords, a device that has not been updated, a device that has been placed on the internet when it shouldn't, older equipment that are not designed with cybersecurity in mind, these types of things, not highly sophisticated attacks with advanced capabilities from attackers. I think this is important for your sector. It's not the case in all sectors that we observe. If we look, and when it comes to what measures you apply already in the sector, we do an annual study where we ask the companies that are in scope of the NIS directive, and in this case it's drinking water. From next year we will include wastewater companies as well. We ask them various questions on how they spend the money for cybersecurity, whether they have a cybersecurity team, what measures they have in place, whether they face incidents, how much the incidents cost. So for them, you can find very interesting information for the sector in this study. It's the third year that we run the exercise. But I included this figure in this presentation. It shows how the companies themselves assess their level of cybersecurity and how mature they feel. And it's, if you compare with the average, the drinking water supply and distribution companies feel that they are a bit lower. And you have to take note that in our sample, it's primarily large companies. So if we extended the same survey to small or medium-sized companies, we have a few in the sample, but it's not a majority. I think we expect to see lower results here in terms of how well prepared they are for cybersecurity. And this brings us to the latest changes when it comes to the policy environment. Earlier in January this year, the second version of the Network Information Security Directive was entered into force, and it brings changes for the water sector. Before, only drinking water companies were included, and they were designated based on criteria selected by the country where they were based. With the new directive, both drinking water and water companies are included. And you see the criteria for being in scope has to do with the size of the company. So medium and large companies have to comply with the NIS2 directive requirements, and I will come back to, I will explain what that means in practice for the companies, while small or micro companies are not in scope. However, there are exceptions. So, for example, if a member state considers that a particular water company is crucial for national security, or they can actually say that you need to comply with NIS2. So it doesn't, if you are a small company, it doesn't mean necessarily that your authority, now the national competent authority, will not enforce the NIS2 directive to you as well. And I mentioned because the water sector is a particular one. It has a huge number of companies of various sizes, and often very small companies or local authorities that do the water treatment. So I mentioned because it's of interest. You should be expecting by mid-October next year the national law that will explain how the NIS2 directive will apply for depending on the country you're based in. This, because it's a directive, it's not a regulation, it has to be transposed into national legislation. Now, what does it mean for a company, for a water company? The NIS2 directive has a lot of tasks for the authorities, for ENISA, for the Commission, for various topics. But I think what's of interest is what the companies should be doing. And the focus is on risk management. So it has three main aspects. It makes the top management of companies, in our case, water-related companies, accountable for complying to NIS2. So if there is an incident and the company does not comply with the directive, the top management has to faces any penalties or any warnings and so on. And the companies need to do two things. They need to apply cybersecurity measures, and I will show you what types of cybersecurity measures they will be, and to notify incidents. These were also prescribed in the previous version of the directive. It's just that they become more specific, and the incident notification will change. The thresholds will be modified and so on. These are the types of cybersecurity measures a company should apply. These are basic cybersecurity measures. The idea is to have the minimum baseline security measures applied by all the companies that are in scope of the directive. And you see some examples, for example, to train your staff, to have a risk analysis process, to have access control, to use encryption, and so on. These are it's 10 categories of measures, and depending on how the directive will be transposed, you will get most likely a more detailed interpretation of these measures in your national laws. The measures need to be appropriate, proportional, and they can be technical, organizational, or operational measures. And they are linked to what I mentioned earlier, that they are basic measures. It's not they are not advanced. When it comes to incidents, if a company has what we call a significant incident, it has to give a first early warning to the national competent authority within 24 hours, and then do the official incident notification in 3 days. And then, of course, because it takes time to see what actually happened, what was the impact, what went wrong, they need to give an intermediate status report and a final report when the incident is considered closed. And of course, depending on you will receive guidelines and instructions on how to do the notification from your national competent authorities. And when it comes to management responsibilities, as I mentioned, management is accountable for non-compliance. Managers need to approve whether the cybersecurity risk management measures taken by the company are adequate. They have to supervise the implementation. This is important because in many cases we see, especially in less mature sectors, top management, throws the responsibility to a small IT department that struggles to implement measures, have no budget, and they do what's humanly possible, but with no resources. So, the legislators were trying to actually highlight the topic in the top management. They have to have some basic training, understand what cybersecurity is, and to train their employees. So it's a two-way training is needed. And with this, I will conclude what we do at ENISA when it comes to the NIS directive. Our role is to support implementation. That means that we try to assist the various sectors depending on their needs. What we do is we work together with the member states and the Commission as we participate in the NIS cooperation group. This is a group that takes the strategic decisions between the various national competent authorities, and we have a role there, and we help them with technical advice, and we participate in their discussions. We are also the secretariat for the CSERT network. This is the network of the national CSERTs. They are responsible for incident response, and they provide assistance. And if you see our past work in other sector, we issue advices, we give guidelines, we organize exercise depending on the sectors, and we create awareness raising material. At the moment, we have material that can be used from other sectors, but we don't have anything specific to the water sector. We're still trying to understand what are the specific needs, and to what we usually do is we do a sectorial analysis to see the threat landscape and the maturity of the sector, and then we design what needs to be done. What we feel helps a lot in these early steps for cybersecurity is to have events, conferences where the community starts discussing on the topic. I think this webinar serves such a purpose, and I'm very happy to be with you here today. In some sectors, we try to establish EU-based information sharing and analysis centers. This helps people understand what they are facing and share good practices. And as soon as we see a specific gap, we may issue a guidance. For example, in the health sector, we gave guidelines on how to procure products and what cybersecurity requirements to ask. This was a need identified at some point. So we are open to hear what you actually need. We will continue to monitor, of course, the cyber threat landscape for the water sector as well. And I look forward to see what the other speakers will say, and also the Q&A to see what your worries and the concerns are. So thanks a lot for the time given. Back to you, Arthur. Thanks.
Thank you very much, Marianti, for the presentation and a good overview of ENISA's activities and upcoming one as well. So please, for the participant, please use the chat and Q&A function for your questions. We'll now we'll move to the next speakers and have three short impros from our three next speakers, and then we'll make one table where we will take all the questions from the participants. So our next speakers is Slavko Velicko from Global Advancement Director, Water Industry at Bentley System. Slavko Velicko is as I said, is Advancement Director, Water Industry at Bentley System. He heads up a team of professionals that delivers Bentley digital water twin solution globally. Slavko further develops new markets and business opportunity with channel partners and added value reseller. Slavko, you have over 25 years of experience in the water industry in all phases of infrastructural project development, financing, and implementation. And today you will talk about from gray to green, pioneering carbon reduction in the water industry. Slavko, the floor is yours.
Thank you very much, Arthur, for your kind introduction. So good morning, everyone. Today's presentation will be focused on, as we are talking about cybersecurity and cloud power solutions in order to monitor and maintain and of course, get a visibility and insights of our operations of water and wastewater treatment plants. I'll be touching a little bit upon the digitalization and the cloud-based solutions for the water industry as well. So just a brief introduction to the company. Bentley Systems is a Nasdaq-listed company. We are delivering software solutions for designing, building, and operating the world infrastructure, including water and wastewater infrastructure as well. So as an engineering company, obviously, we develop engineering solutions for the water industry as well. So in terms of the digital solutions solving today's global challenges, obviously, water and wastewater treatment plants, which is the focus of today's presentation, need as capital investment projects. They're very expensive, but also throughout the life cycle, we need to improve definitely their efficiency. And I will be talking a little bit more in depth regarding some numbers regarding water and wastewater treatment plant. What we see in Europe, for example, in the Netherlands, majority of the staff who have a lot of tacit knowledge of operating this type of capital facilities, basically, they are going to retire. So we need to capture, obviously, their knowledge into data-driven algorithms, into documents, etc., to make available for the younger staff to take over. Sustainability is playing an important role. And every water company, of course, is linked to the sustainable development goal. Our company is heavily investing in technology that supports sustainable development goals. And water and wastewater, out of the 17 sustainable development goals, are touching at least 5 or 6. We see a lot of increased regulatory pressure, including from the European Union as well, which is the Urban Wastewater Treatment Directive, which is now in a revision. But we have also regulatory bodies like OFAT in the United Kingdom, and also other like environmental agencies, etc., which are putting pressure on how we should operate and emit, for example, towards the environment in terms of our water and wastewater treatment plants. There is definitely a rising cost pressure, which is there with the electricity. We have seen electricity costs skyrocketing because of the energy transition in Europe. So how we can make our wastewater treatment plants more energy efficient, it's really the aim. And some energy reduction target, for example, European countries and regions often set specific targets to reduce energy consumption in water and wastewater treatment plant, aiming to 20 or 30% at energy savings throughout various measures, where digitalization definitely plays a role. And finally, I would like to mention technology and innovation, obviously. So we shouldn't be afraid. In the water industry, we are quite traditional. And also the previous speaker demonstrated that in terms of cybersecurity, self-assessment, etc. So we need to push the boundary and embrace technologies like digital twins, etc., in order to improve efficiency of our water and wastewater treatment plants. In terms of the digital technologies, how they are changing and shaping the water and wastewater treatment plants efficiency, I will mention few topics. Decarbonization is playing a very important role for European Union, so reduction of the greenhouse emissions, obviously. Just to give you an idea, water and wastewater treatment plants are responsible for a notable share in carbon emissions, with some large facilities emitting hundreds of thousands of CO2 annually. And with the renewable energy adoption, EU aims to increase the share of renewable energy in the wastewater treatment plants to around 50% by 2030 throughout the Renewable Energy Directive. And many water companies, for example, here in the Netherlands, Evides, have put on their internal targets, basically they become a carbon neutral or net zero up to 2030. So quite aggressive targets and goals. And without digitalization and proper understanding of the processes and how we can optimize the processes in the water and wastewater treatment plants, this is probably impossible. Environmental impact is a key factor as well, like nutrient removal targets. EU regulations require wastewater treatment plants to achieve specific, for example, nutrient removal target, such as nitrogen reduction to come below about 10 milligram per liter for discharged into sensitive areas, for example, then sludge generation, how to come and go around regarding the circular economy and reuse of sludge. So sludge can be reused for agriculture, for example, can be used for biogas production, etc. Then we talk about resilience on the climate change as well. So impact of extreme weather conditions. We have seen that many of the facilities are designed for a calm waters, for steady waters. If a water treatment or a wastewater treatment plant has a sort of a dynamic flow, which is also comprised from some runoff, etc., together with a dirty flow. So we cannot treat that water and we need to release it into the environment, into the receiving water. And for that, of course, huge penalties are paid to the environmental agencies as well. So predicting all of these flows which are coming to the wastewater treatment plants in order to not disrupt the primary, secondary, tertiary treatment is a key factor where digital twins and cloud-based solutions can definitely help. And resource recovery, I touched upon a little bit the circularity and resource recovery. For example, many of the wastewater treatment plants in the Netherlands are producing also biogas. So that can significantly also reduce the amount of, for example, energy requirement from the biogas, anaerobic digestions, etc., which can be used for energy generation. Some large facilities also produce biogas and heating water that can be also put to the power companies and heat up homes, for example, for thousands of households, etc. And finally, phosphorus recovery as well. So efforts to recover phosphorus from the wastewater are gaining traction in Europe, with some wastewater treatment facility extracting several tons of phosphorus annually, which are very important, of course, for agriculture as well. So these are some of the topics, and how do we address that? So in Bentley, we have developed a couple of digital twin solutions. Digital twin solution is basically a digital replica of the water or a wastewater treatment plant, and of course the networks which are feeding those plants as well. In order to provide visibility, insight, and real-time decision support in the digital system, which is replicating the physical infrastructure as well. I will mention just two cloud-based solutions, because today we are talking about the cloud, the cybersecurity issues as well. So WaterSight is our cloud-based solution for monitoring and getting visibility and insight of water and wastewater networks, which are really important, which are feeding, of course, and connected to the water and wastewater treatment plants. And on the plant side, we have PlantSight, which is basically a digital twin for monitoring, operation, and improving efficiency of any type of water and wastewater treatment facilities. Just a few videos, just like as a teaser. So if you develop a digital twin for a plant, you can have, 3D environment if necessary, like a BIM environment to put all of the as-built drawings. If some of the wastewater facilities doesn't have as-built drawings, we can fly a drone, scan with millions of points, and then automatically detect all of the elements and the assets. So this is an example of, zooming to a certain asset in a real-time monitoring of, for example, vibration, temperature, pressure at the pumping station, screw pump, for example, at the wastewater treatment plant, and getting automated alerts. For example, if the pump is becoming too hot, if there is, for example, a vibration or a water ingress, it will generate a work order for the plant operators in order to inspect and potentially also replace certain elements as well. So just to give you an idea how these cloud-based solutions are used in. So this is an energy consumption dashboard that on the wastewater treatment plants, also the sludge production, we can also zoom into certain, time series in order to detect events even before they happen, and all of these events and alerts can be sent to the operators and the right asset managers in the organization in order to take certain action. A couple of case studies. So how these digital twins are helping utilities around the globe in order to improve their efficiency, the points and challenges, the business challenges I just discussed at the beginning. This is Northumbrian Water. One of the key business challenge was also to reduce pollution incidents, as I mentioned, during, let's say, a rainy event, because sometimes we have a combined sewer systems, we cannot separate the rainy water. It comes definitely to the wastewater network, and of course, Northumbrian Water is operating a sewer network of 16,000 kilometers of pipe and more than 400 wastewater treatment plants, as you can see. So having a implemented digital twin with some data analytics, 4D analytics as we call it, so it helps them basically predict the rainfall and the runoff. It helps them predict the inflows into the wastewater treatment plant, including all of the parameters, which are very important for the treatment and the effluent at the end of the day, and to predict the pollution incidents before they happen. So you can see here that what are the key benefits: reduction of false alarms. With a good predictive model, it's possible, to accurately predict the potential sewer overflows, combined sewer overflows, sanitary sewer overflows, reduce energy, engineering callouts and asset management inspections, etc. Increase response time for the operators and also communication with the citizens as well. And finally, reduce pollution incidents by 50%. Any pollution incidents can be also, publicly public damage to the company can result, but also financial implications as well. This is another example with Yorkshire Water. So Yorkshire Water had a business objective and a challenge to become one of the top performers within the OFAT. OFAT is the regulatory body who has a special KPIs incentivizing utilities to of course improve their efficiencies. So they use similar digital twin, data-driven digital twin, in order to benchmark the performance across all of the sites and all of the wastewater treatment plants, and streamline the whole operation. So operating costs like energy, I was talking about, like environmental impact, like asset management, etc. Key costs which are very important for these capital installations and facilities. So you can see here the operating cost reduction of 18%, almost 48 million per year. And with this technology, Yorkshire Water became one of the first and best performer in the OFAT regulation. So some thoughts to conclude. I showed you a little bit how digital twins technology and cloud-based solutions. I'm here pitching a little bit the cloud-based solutions because of the topic of the cybersecurity and the potential discussion in the panel session. But I wanted to mention that some thoughts to conclude. Of course, water should be prioritized, and we have seen that the NIS2 directive, which is coming in terms of cybersecurity, the urban wastewater treatment directive is in a revision at this point in time between the trilogy, between the European Commission, European Parliament, and the European Council. So that will also drive further efficiency improvement, path the net to zero, of course, till 2030. Then adoption of digital technology. It's digital technology is just a tools, it's not the means, but we have to use the digital technology in order to realize business outcomes and solve these pressing challenges. And of course, holistic, forward-looking approach for the infrastructure in Europe is needed, not only for the water and wastewater sector, because it's touching energy, even on-the-spot electricity, trading, etc. Electricity prices fluctuates enormously during the day, during the week. So there is a touching point to agriculture, touching point to our sustainability, of course, and environmental impact as well. So thank you for the opportunity, Arthur, to present at this webinar. If you wish more information, you can contact us on these email addresses. So my email address is there, Bernardo, who is our EU liaison in Brussels, and also Neda, who is our industry marketing expert. For some case studies, please reach out to us and we can send you. So thank you very much. Over to you.
Thank you very much, Slavko, for the presentation. So please again use the chat and the Q&A function. We'll now move to the next presenter. Next presenter is Dan Buchenhout from the KU Leuven. Dan, you are a civil engineer with special interest in hydrology and data analytics, and you will talk about the an Erasmus program, Erasmus Plus program from the European Union DG Water, where EWA is also taking part into the consortium. And within DG Water, you are involved in organization of digital water living labs and digital water curriculum, and you're also the work package leader on dissemination and exploitation. And you also recently started a PhD under the supervision of Professor Dr. Patrick Willems, and you will focus on data-driven food modeling. You will now be talking about digitization of water industry by innovative graduates water education. Dan, the floor is yours.
All right. Thank you, Arthur, for the very complete introduction. Indeed, this morning I will be presenting the DigiWater project, and that's also the reason why I'm here. In short, DigiWater is about the digitalization of water industry by innovative graduate water education. That's a mouthful, but I will come back to that later on. DigiWater is an Erasmus Plus project, so funded by the European Union. Erasmus Plus means, of course, that there are students involved. So we have students' mobilities going on within the project that I will mention on later on as well. In short, maybe to give a bit of a structure to the project, there's 6 countries involved. So we have partners from Norway, Germany, Belgium, Romania, Cyprus, and Turkey. Each time we have a university, so a local university, in our case, that's KU Leuven for Belgium, and an SME, so a small medium enterprise, in our case for Belgium, that's Sumaka, which is actually a spin-off from KU Leuven, involved within the project. So in that sense, it's quite of an innovative project already, I think, because we have both industry and academia involved within the same project. And that's, of course, because we want to identify problems or needs within the enterprises, within the water sector that we can tackle through graduate education, which is on the university side as well. Of course, EWA is also involved as an umbrella organization. So they offer us these opportunities like today to share our experiences from within the project, to share our achievements with a wider group, of course. Today, I want to talk about 3 main parts or 3 main pillars of our project. You can see here on the figure, we have the structure of the project, and we're mainly going to focus on the middle 3. So it's about digital water needs analysis. That's, of course, where we start. We have to identify, okay, what is really lacking? What can we try to tackle? Second of all, we're looking at digital water curriculum. So that's really on the university side, the graduate education. What can we integrate within our existing education systems or courses to really focus more on this digitalization that is so important? And then last of all, I want to discuss digital water living labs, which is really the application of innovative ideas within the water sector. Because as we heard already in the previous presentations, the water sector is rather traditional. So we like to stick to what we know. But of course, there's many new technologies out there that we can use to empower our systems, also within the water sector. So to go back to the title, so digitalization of water industry by innovative graduate water education. So one part is really the graduate water education. The other part is on the innovation and the application of innovative ideas. So that's the Living Lab. So first off, the digital water needs analysis. We got together with many stakeholders throughout the sector, from academia, government, industry, in workshops, but also questionnaires, to see, okay, where is the problem when it comes to digital water, which is quite an open question. The main feedback we got was on data, really. We see that most people are concerned about data availability, both in terms of just the sensors being out there. For example, if you're building a system to monitor rivers within, for example, within Flanders, let's say, within Belgium, you need a lot of sensors. These have to be available, but also of high quality. The data has to be assessed, but also has to be stored. And ideally, we want to store the data for a long period of time so we can do historical analysis on those. So that's one concern. But it doesn't mean that if the data is available, that it's also public, that it's shared. So it's also about ownership. But if you want to share data, it's also important to have a similar or some standards in the format of this data. Also in terms of sharing the data, so the APIs, to share the data with other partners online. It's important, and that's what we hear from everyone, both from academia but also industry, to have a uniform data sharing practices. And then lastly, this couples back to, of course, data availability and data sharing, is the integration of these data sets into existing monitoring tools, for example, but also in digital twins. As Slavko also mentioned earlier, this is a very important tool for wastewater treatment processes, but for many other processes involved water as well. And also integrating of existing data within existing IoT systems, for example. But that couples back to data sharing in the uniform formats as well. A second aspect, and that's of course where we are mainly interested in, is the digital skills mismatch. So we see there's a mismatch between the water industry and what they're expecting or asking from young junior water experts. So mainly related to their digital skills. That's something that Slavko also mentioned, I think, that there's a lot of older staff that will be replaced by junior water experts coming from universities. So it's important that they are equipped with the right tools to actually make that succession very successful. So that's the second part, graduate water education, what we will be focusing on, especially. I took 2 graphs as well from one of the reports that we made. So we see that there's a large portion actually of the respondees to our questionnaires that agree that there's a significant mismatch between the skills from the academic curriculum and the industry's demands, let's say. So here on the figure, for example, you see that there's only the green part, only 50% says that there's an insignificant mismatch, and all the others agree that there's a moderately to very significant mismatch. The figure below, I'm sorry, the colors are inverted. So here it's the orange color that we're looking at, means that junior water experts are well prepared for changing needs in the water industry. Only 16.7% agree to this. And the others say they're moderately to not very well prepared. So I think there's indeed some work to do on that aspect. Moving on to the curriculum very shortly, based on the feedback we received in these questionnaires and workshops, we devised two curricula, one on big data and one on Internet of Things. And the idea is that we develop modules covering topics like, for example, visualization within big data or big data analytics. So introduction to building models using all these data sets, this big data sets. And the idea is that by developing these models, we can hand them out to universities, not only within the consortium, but also outside of the consortium, to give them inspiration to integrate this new material into their existing courses. I think that's our best shot at that really changing something. So we devised these two courses, big data. So as I mentioned already, visualization is an important aspect, big data analytics, so building models based on this data, but also cybersecurity, like Marianti mentioned. It's a huge topic, both in big data, but also in the other course that we are developing on Internet of Things, so more on the side of the sensors. I think cybersecurity is also there, very much an important issue. Moving on also to standardization and doing some case studies to inspire the students, focusing on data assessment. As I mentioned earlier, it's important to verify that your data is really useful, that it's not, there's no error in the sensor measurements, for example. So those are all things we're trying to cover in the big data course. And then in the Internet of Things course, we're looking really at the technical aspect of sensors, different types of sensors, but also at established systems like SCADA. I think most of you will be familiar with that. Also standards and good practices on that side, and case studies and future trends. Of course, more information available on our website. I will show a QR code later on if you want to dive into our reports, but I'm only trying to give a very short overview of our project, which means we can already move on to the last pillar or the last achievement I want to discuss, which is on the digital water living labs. And one important aspect there is the innovation camps that we hosted. So as I mentioned in the beginning, DigiWater is an Erasmus Plus project, so we facilitate student mobility. To that end, we organized two innovation camps, one in Leuven, here in Leuven in Belgium, a week of students coming to us from all the 6 countries within the project consortium, where they get together with local experts. We had people from the city of Leuven involved. They could present problems and issues that they are facing within the water industry, which then the students try to tackle by doing group work, group assignments, so prototyping, and in the end, they can pitch their pen and paper solution to the problems in a pitching competition. We did that twice, so once in Leuven, once in Istanbul. In Leuven, we focused on big data and IoT, and in Istanbul, we actually focused on cybersecurity. So we had a lot of interesting lectures as well, because most students are not that familiar with the topic. So I think it was quite successful because we had over 50 students participating in each camp. So as I mentioned before, from all 6 countries. So it's interesting to get students with different backgrounds, both culturally, but also by education together and to work on these problems. But to be honest, this was only really the start of the living labs. So the students could come up with some interesting ideas, do some pitching, and the most interesting ideas were actually selected for a continuation. So we see this first step as an ideation phase. So we have a problem statement, getting together with stakeholders, just thinking about potential solutions. But after this, the students were given a lot of feedback about a project consortium. And they had 6 more weeks to finish the prototype, so their pen and paper exercise for a new evaluation, after which the nicest ideas or the nicest prototypes were selected. And after that, they were guided in a 6-month trajectory in a rapid realization phase, we call this, to actually come up with a pilot. So something that's kind of works. So there was been a little bit of programming, so they have some kind of model, some kind of something to show actually. And But the problem there is that we often did not have realistic data sets. So the next step is really to work together with end users, stakeholders, using their infrastructure or just their data sets to see how well actually these solutions worked. To give an example, because this sounds a bit abstract, I realize, one example we did here in Belgium is a water balance model. So we have a canal. We know in summer periods there's a problem with water availability. So one way to try to model this is to model all the inflowing water and outflowing water. So one of the students developed a model to do that based on literature. And we actually tried to implement that with the end user data. For example, they have all the different locks on the canal. There's a lot of flows going from the different parts of the canal to the others. We got some data on that, which was actually very interesting to implement in this model because it made the model much more better. So this is one of the use cases. In wastewater treatment, for example, that's one of the students in Turkey that developed this. There was a system on identifying risks within the sewer system for specific nutrients that were, for example, if there's an attack or specific chemicals injected into the sewer system, the system could detect it very quickly and send out alerts. And this demo case was more about, okay, how do we do this alerting? Who do we contact? And so on. So that was very shortly the DigiWater project. It's still ongoing. So we're still finishing these demo cases and we're still finishing the digital water curriculum. But actually the digital water needs analysis has already been completed. So if you're interested in that, you can check our websites, you can scan the QR code. But of course, also, if you're interested, follow us online. We are available or present on LinkedIn. For those of you that use Instagram or Facebook, you can also go there and follow us. Thank you very much for the presentation, and thank you to the other speakers as well. Looking forward to the discussion.
Thank you very much, Dan, for the presentation and all the information about this DigiWater project. We'll now move to the next speaker. The next speaker is Johannes Lohaus. You live in Germany in the Eifel. You are the Deputy Chief Operating Officer at Sonnentechnik. You are responsible for the sale calculation. You are responsible for the sales, calculation, and procurement department. You studied operations management, and you moved a bit, I would say, during your studies between Aachen, Reutlingen, and Dublin. And during your studies, you began to focus intensively on topics such as digitalization, automation, and standardization. And you are able to expand those experience daily on your job. And today's presentation will be about digitalization and artificial intelligence in a sewage network. So Johannes, the floor is yours.
Thank you very much, Arthur. Yes, I want to show you, hello from my side, I want to show you one project example where we, Sonnentechnik, implemented an AI and artificial intelligence in the sewage network. So just a few words to our company. Sonnentechnik is a solution provider from Germany. We were founded in 1958 as a plant constructor. So our key competencies are electrical engineering and mechanical engineering. And over the years, we focused very much on digitalization and standardization, also on process engineering, where we developed our own digital products, such as our control cloud, which is a SCADA system that I will show you today a little bit. As of today, we have 160 employees based on 2 places in Germany. And the project example I want to show you is for a municipality, Stadt St. Wendel. It's based in the Saarland region in Germany. And the sector is the sewage network in that case. So the client approached us with a few goals. He was looking for a reliable process control system, so a new SCADA system. Obviously, there was the goal to ensure a future-proof IT security, replacing the existing local system, which was very old, with a cloud system that's state-of-the-art. And also there were a few structures that had no power supply. So for a good working artificial intelligence, there had to be collected more data on places where was no power connection. So we had to integrate battery powered measuring devices. And yeah, the big goal behind it was basically because it was mentioned before of the other speakers, we have a shortage of skilled employees, and we have to make sure that these operating employees save time. So artificial intelligence and digitalization is necessary to save time. So this was the big goal behind this project. A few numbers to the project. In this case, we had to implement 14 pumping stations in a urban area, and also, as I mentioned before, 10 rainwater basins without any power connections that had to be integrated into the data system. And yeah, we developed an artificial intelligence for clock detection and also clock prediction for pumps and throttle devices in the rainwater basins. And with that artificial intelligence, we build up an alarm system that warns the operating personnel before clogging happens, so that they can prevent clogging in the sewage network. And the achievements, to give you a little overview, was the implementation of the artificial intelligence and the analyze of the data automatically to save time and support the operating personnel, and reduction of energy costs because, and also reduction of license fees because of the cloud system. So if you don't have a local server on site that consumes a lot of energy, but you use a cloud system where you share a bigger server with other clients together, the energy consumption for every client gets lower. Yeah, how was our approach? Availability of data is a big topic, and as a plant constructor, we are able to deliver everything from one single source because it's multidisciplinary what we have to do to build up an artificial intelligence that is able to add value to save time. So at first, we have to look at the structures as they are, which data is already available, which measuring devices are there. For example, the structures without any power supply, we had to find the perfect measuring device with a battery for that individual use case. So every structure has to be analyzed. We have to look at what data is already available and what further data is needed and how can we collect it most efficiently. When we have all that data collected, we have to connect the data. To give you an example for that, when we have a pumping station, we can look at the power consumption of each and every pump in relation to the flow rate that the pump produces. So let's say there is a clogging going to be happening. The power consumption of that pump will get higher because it has to work more to get the flow rate up. And at some point, the power consumption will go way up and the flow rate goes down. So the relation between those two parameters will predict the clogging of the pump. So we have to connect all that data, and that's an individual process because every structure has its very unique data curves. And that data has to be transferred to the cloud-based SCADA system. In that case, when you work with that data and analyze it and look at correlations, a cloud system is the right choice, because on a cloud system, you have a very big server behind it where you can do much more calculations with that data that you could do locally. So and the third step is to develop and train the AI. So as I mentioned before, you have to look at the correlations of data. Some correlations might bring up wrong conclusions for the AI. So all that has to be analyzed and optimized. And by that, you get an AI that is able to add value and save time and help your operating personnel. And only then AI is beneficial for the operating personnel. So yeah, the result is a AI-supported monitoring systems that helps the client in this case to operate their sewage network most efficiently. So what we implemented was an automated evaluation of clogging behavior in all sewage structures. We created transparency in a widely distributed urban area. So before the implementation of the AI, the operating personnel had to drive to every sewage structure frequently, like at least once a week, sometimes once a day, to take a look at it. Is it still efficiently working, or is something wrong? So that we could reduce, because that on-site inspection of the pumping stations and rainwater basins was reduced to an absolute minimum. So you cannot reduce it to nothing. Sometimes you have to take a look at the structures, but not that frequently as before. Yeah, so the workload of the personnel was reduced significantly, and they can use their time for much more important things. We all know the struggles in the water industry, so time is very valuable for operating personnel. The operational safety was increased by implementing the cloud-based SCADA system, our control cloud. On different levels, it was increased, because on the one side, the operations of all the structures was improved, because before clogging happened, they could be stopped. And also the safety was increased because the IT security was updated with our cloud system. Yeah, and we could reduce power consumption of the SCADA system in total by bringing the SCADA system into the cloud to a shared server and not on a local server of the client. So yeah, this was a little project example how in reality AI helps even today customers. And also one of our news clients is a big airport in Germany, and in regards to cybersecurity, they have some structures that are outside of the security area. So they decided specifically for the monitoring of data. So no remote control, but only monitoring, to go to a cloud system that is outside of all the internal hardware and structure, so that they cannot be compromised. So also in that case, a cloud system with AI is the most secure choice. Thank you very much for your time.
Thank you very much, Johannes, for your presentation. Thank you very much again to all speakers for joining us today. And we are exactly on time, as according to the agenda that was published on our website. And we'll now move to the Q&A rounds. And I will then kindly ask all the speakers to switch on their cameras, please, again. And we will take the questions that are slowly starting to pop up into the chat. And the first one would be for you, Slavko and Johannes. And I think, Johannes, with your last intervention, you starting answering it a bit. And it's from Peter Budais that's asking you, then Johannes and Slavko, how do you address cybersecurity challenges regarding cloud-based solution, thinking about the need for connection between the cloud and the brands? So I don't know, maybe Slavko and Johannes, if that's
I
fine
can
for
go,
you.
no problem.
Yeah.
Thank you, Arthur, and thank you for your question as well. So in terms of the cybersecurity, of course, also our previous speaker, Martiani, talked a little bit about it. It's really important to understand the risk and also how to mitigate the risks as well. So in Bentley Systems, we are working with partners, cloud providers, which is in this case Microsoft. So our water and wastewater digital twins are residing in a Microsoft secure environment, which is constantly assessed by cybersecurity experts as well. So risk assessment and vulnerability assessment is there, access control and authentication, network segmentation, physical as well. Sometimes clients want, dedicated clusters and servers for them. Then, of course, security policies, training, certification of the water staff, operators, especially with the SCADA systems, but also asset management people as well. Incident response plan is very important to have in place. If something bad happens, how to mitigate the risk and how to respond to any incident. Data encryption, all of our transfer of data takes place into a secure environment, and data encryption policies, obviously. Monitoring tools, which are constantly monitoring the cloud services and intrusion. We have that in Bentley together with Microsoft as well. Physical security, who has access to the data centers, for example, here in Amsterdam, for example, or in Brussels. A supply chain security, so who is working with a water company, which organization we need to assess also the cybersecurity aspects and certification of the supply chain, especially OEMs, etc., which are supplying, for example, seals, bearings for the pumping stations, screeners, etc., some chemicals. So this has to be assessed as well. And finally, I would say regulatory compliance. There is definitely a regulatory compliance which is very strong at this point in time, and we heard also from Marianti as well regarding this regulatory compliance. We need obviously a good regulatory compliance in place in order to ease the acceptance of the cloud solutions as well. Sometimes when I talk to the water utilities, they are very traditional and very scared regarding the cybersecurity. But the first question is to ask them, do you use Gmail? Do you know where is your bank account, etc.? Do you feel secure regarding your bank account, etc.? So those type of discussions, open discussions, we need to have them because cybersecurity is an issue, but also cloud solutions provide a lot of benefits as well. And some of the benefits I think Dan mentioned as well, and Arthur mentioned, you mentioned as well in the beginning. So there is obviously a lot of benefits in terms of cybersecurity, in terms of energy efficiency, but also in terms of software upgrades as well, because the software upgrades are done by the professionals, during the night, etc. And next morning, you are just running the up-to-date secure environments, which doesn't require any installation of patches, etc., in the water utility themselves. So there are a lot of benefits, and let's talk about also the risks, but also the benefits of the cybersecurity. So, Johannes, if you want to contribute a little bit to this discussion.
Yeah, I totally agree with what you said, Slavko. One thing I might add is, with also furthermore to the server cybersecurity, we have to look at the security of the sewage structure and the water structure itself. So the hardware that is built inside the electrical cabinet has to be chosen wisely. So we I don't want to promote any specific hardware a supplier here, but you have to look at a router with a firewall that is safe. You have to build up a VPN tunnel from the structure to the server. That is, all the ports that are not needed are closed. And you have to look at two-factor authentication for everyone who might be able to remote control a system, so that the PLC system inside the structure cannot be compromised, so that there's a hard barrier between it, so that from outside you cannot you can not get in contact with the hardware on site.
Perfect. Thank you very much. We'll now move to the next question from Try, was for you, Johannes, again. How do you ensure the operators to trust the AI? And just before, apologize for the chat. We'll keep it friendly, everyone, please. And we continue then to the next question, Jonas. Thank you very much.
Yeah, that's a really good question. Obviously, there is mistrust in the first steps to the AI, so it has to be trained, and the operators, the operating personnel, has to be involved in that training. So at some point, they will see the AI as one of their own, and then they trust it. So there's a process. It's change management, which has to be done. But as soon as you have the first benefits because of the AI, it's accepted from our experience.
Thank you very much. Does any of you wants to add something, or do you have any questions? One among each other, or whatever, or again, for the participants, please use the Q&A function. Otherwise, I had maybe more a question or to open the floor to you, Marianti. You mentioned before working more for, let's say, on the drinking water side with ENISA, and that the wastewater side will come now. Do you have maybe, I would say, any tips, advice to the wastewater, let's say, as an operator's side on how to, let's say, kick it and to start on a smooth path and on a good start, and to, I would say, potentially try to increase a bit the cyber risk management maturity self-assessment node for the water sectors. Thank you.
I'll be very honest with you. I don't have visibility on whether the wastewater companies differ a lot with respect to the drinking water. It's just that because the drinking water was in scope of the NIS directive, we run the survey with respect to their maturity for 3 years now. My impression is that it could be that they are the similar maturity level. I'm not sure. I cannot give you an informed opinion on this. However, since we see all these initiatives moving to the cloud, using AI, also improving the, modernizing the equipment being used in both drinking water and wastewater, I think a lot of emphasis should be placed from both drinking water and wastewater on the basic cybersecurity measures. Because a bad passport policy will affect you whether you are in the cloud or not. There are additional measures, of course, offered from the big cloud service providers, but if you don't configure them properly or you don't utilize them, again you have an issue. So I think for both sectors, the basic cybersecurity measures should not be taken for granted, in the sense that they are, because they are basic, they're implemented necessarily, and especially with all these initiatives for digitalization that take place now. I would be really interested to see whether there are substantial differences in the wastewater sector, but I cannot give you a more informed opinion on this.
Thank you very much, Marianti. And yeah, I mean, if any of the speakers want to share more experience also on this, but I'm also a bit happy to hear from you, Marianti, that to, let's say, in a way, to say we need to still work on a basis, because sometimes when you hear cybersecurity, you can think, oh my God, what's going on? I need to hire, I don't know, 10, 20 new people for the IT departments to have everything under control. But sometimes it's also just the basics that just need to be there and implement first.
Even Dan touched on this topic, even hiring new employees, younger ones that actually had a course of cybersecurity at some point in their life can make a difference in any type of work that you employ them for. It's not just the IT department and the maybe cybersecurity officer that you may recruit, but it's also the general, it's the majority of your employees. It's not just a small group of people that need to have this knowledge.
So maybe, Arthur, I can shed a little bit of light as well, using my international experience, obviously working on a global arena. So definitely potable water is a little bit ahead of the game in terms of digitalization, implementing SCADA system, implementing decision support system, which are AI powered. But we see a trend also in the wastewater utilities industry as well. Take Aquafin in Belgium, take Vitens Evidence here in the Netherlands, take all of the UK water utilities, Polish water utilities, by the way, which are also aspiring a lot towards digitalization. We see that wastewater networks are also digitalized in a way that we know where are the pipes, first of all, where are the assets. Secondly, we install also some IoT devices like flow meters, water levels, for example, CSOs detectors, etc. And finally, in every wastewater treatment facility, state of the art, we have SCADA system. We know how much water is coming, what is the quality of the water, how much water is pumped, what is the resident time, what is the velocity, what is the effluent quality of water in terms of phosphorus, heavy metals, etc. So we see a lot that these digital technologies are taking place in wastewater utilities as well, and they can benefit from these digital twin technologies, whether in the cloud, whether on-prem, or a hybrid combination as well. So we see that this wave is coming, obviously, and majority of the cost savings that I was talking in the beginning in terms of electricity saving, in terms of preventing impact to the environment, are to the wastewater treatment plants and not to the water treatment plants. So we see a lot of pressure and a lot of, let's say, regulatory pressure put on the wastewater treatment plant to embrace digitalization and implement modern technologies in order to improve efficiency of the same.
Yeah, thank you very much, Marianti and Slavko, for your comments and suggestion on this. And I think, Dan, to come to you, I would say, yeah, it's really important. I think, as you showed us, there is a need for cyber, let's say, some modules, at least in courses for cybersecurity. I think we all see it here. Do you want maybe to develop a bit more on where do you stand right now for the modules and all of it, please?
So the drafts of the models are finished. We're now evaluating them with external partners as well to see if they have additional input, if you have additional topics to include there. But in the end, I agree with Marianti. It's important that we offer some lectures, some material to the students. It's not the goal that we make experts in the topic of cybersecurity of them. It's not the goal to make expert machine learning engineers of them by giving them a course on data-driven modeling, for example. But it's more to make them aware or familiar with these topics so that they are better suited to work together in a professional context with people that are experts in these topics, so that they're aware of these models, these technologies existing, and that they have to be taken into account.
Thank you. And then I had just a second question about this, maybe from your experience, and because we talk about, okay, on a company side or so on, but how did the students respond to these modules?
Well, they were very interested. Of course, it's for them very fun to go to Turkey or to come to Belgium, participate in these innovation camps. But I would say that for them, it's very useful as well to do. If I look at my own path so far, so I'm a civil engineer by education, but actually in civil engineering, there's not a lot of programming or not a lot of data source handling or so on. But it's something that we had to learn on the job and takes time. So I'm really in favor of including this a bit more in the graduate education itself. So I think this is true for many students, actually. It's true for all my colleagues, at least, doing research here at the department.
Perfect. Thank you very much. Yeah, I think it can also help them in the future to get jobs that could be a decisive element on the either CV or application that they already get some knowledge on it. So I think that could be a key message for everyone here also working or connected with as a higher education university or so on to, let's say, keep promoting that topic for them. I don't think we have any more questions. I think we from the chat, or if you have any questions, comments, or if yeah, one small word if you want to finish something. Otherwise, we are reaching the end of our webinar in I think 4 minutes. Marianti, I don't know, maybe I have to admit I was not really entirely aware of ENISA. I mean, I knew it was there, the activities, not that much, because it's not a topic that I was following before. So I'm really glad I had the chance, or we had the chance to have you here and to hear a bit about what you do. And I think yeah, we have a questions in the chat for you, Slavko, quickly. What's Bentley providing for university? Are there any twins for lecturers available?
Thank you for the question. Yes, so Bentley is running an academic program where we provide all of the software free of charge to students and also to lecturers in order to implement this type of technology in the curricula as well. education.bentley.com. And you have to register there and prove that you're a student with your student pass, and you can download any software from Bentley and any training and learning material. So education.bentley.com.
Perfect. Thank you very much. And yeah, Mariantia was saying was again really nice to hear from ENISA and what you're doing. I think we will hear about it more and more, especially in the water sector now, with not only the drinking water being under, let's say, your responsibility or being in touch with you, but also from the wastewater part as well. I would like once again to thank all of our speakers, Marianti, Slavko, Dan, Johannes. It was a pleasure to have you here. I would like to thank all the participants for taking the time to join us today online. And we'd like to also thank Bentley again for the sponsorship for this webinar that allowed it to have it for free for the participants. And I will just quickly share my screen again for the last two slides from our side, the EW European Water Association Secretariat. So thank you. So PowerPoint will be presentation will be shared with you after the events, and so a video will be uploaded on YouTube either the end of the week or early next week, so you can have access to the recording as well. Please have a look at our upcoming events, where I think you will see a couple of either participants or speakers or at least institutions there. So we have an introduction course on EU water policy and legislation. Next week, we will be at the International Water Association Congress and Exhibition in Kigali, in Rwanda. And we have our two or three main events for next year already. An international conference on water in sensitive and protected area in Pula, Croatia, that will take place in April. And in May, we'll be at IFAT Munich 2024. And please use the EWA_2024 code for a free access entrance ticket for the IFAT. You can also find it on our social networks, and also a water management changing condition conference that will take place in Munich as well. Feel free to join us on either X, LinkedIn, Facebook, YouTube, and to download our to register for our newsletter where we shared everything. Thank you very much once again for everyone, and a big thank you for all the speakers for taking time today. And for the participants, when you close this Zoom, you will get a quick survey to provide feedbacks about today's session. So please take the 2 or 3 minutes to do it. Once again, thank you very much. And I wish you a good rest of the day. Thank you.
Thank you. Bye-bye.
Thank you. Goodbye.